Okay, this is a really short video on factor theorem. So basically, factor theorem states that if x minus a is a factor, if the polynomial f of x, if and only if the f of a equals 0. So this is very similar to remainder theorem, where we were substituting in an x and we had a number as an outcome. Sometimes it was minus 40, sometimes it was positive 230. But in this case, we basically want to prove that every time the outcome will be 0. So for the first question, so these are all past paper questions. I think I've got 3, maybe 4, I can't remember. So we've got to show that x minus 2 is a factor of 6x cubed minus 13x squared plus x plus 2. So to do that, like I just said, we substitute in our a, so in this case x, so if we make it equal to 0, x minus 2 equal to 0, x is therefore 2. So we're substituting in x equals 2 into our equation, very similar to remainder theorem, and we hopefully come out with an answer of 0 to prove that it is a factor. So we're going to do 6 times 2 cubed, so instead of x cubed, I'm doing my 2 cubed, take away 13 times 2 squared, plus 2 plus another 2. So you can work this out step by step if you wanted to. So 2 cubed is 8, 6 8s are 48. 2 squared is 4, 13 times 4 is 52, so that'd be minus 52. Add 2, and if you put all that in your calculator, you do get 0. So it is proved. X minus 2 is a factor because when we're substituting in x equals 2, the answer is 0. You can then use that to further on to factorize fully. So this is a cubic, so that means it has 3 solutions. So you know one solution is x minus 2, and then you would need 2 other solutions to that equation. So it would probably the next part of the question would be hence factorize it completely. But we're just going to stick with factor theorem today. So show that x minus 4 is a factor of 2x cubed minus 3x squared minus 23x plus 12. So again, let's first our x minus 4, if that is equal to 0, then x would be 4, just to distinguish if it's a positive or negative, basically. And then I'm going to substitute x equals 4 into our equation. So I'm going to do 2 times 4 cubed minus 3 times 4 squared minus 23 times 4 plus 12. So 4 cubed is 64. 64 times 2 is 128. 4 squared is 16. 16 times 3 is 48. 23 times 4 is 92 plus 12. So let's just double check that. So we've got 128 minus 48 minus, minus 92 plus 12 gives us a score of 0. So it is a factor. We have proved it is a factor. So again, like I said previously, this would factorize into 3 brackets, and one of the brackets would be x minus 4. Last one. So again, exactly the same thing. To show that something is a factor, we put this a into our equation, and hopefully we get out 0. So this is a different one because in our previous ones they were both minuses. We had minus 2, minus 4. In this case it's plus 3. So when x plus 3 equals 0, x would have to be minus 3. So very, very careful on this one because we've got negatives. So we're going to substitute in x equals minus 3 into our equation. We're going to do minus 3 cubed plus 4 times minus 3 squared minus 17 times minus 3, careful there, take away 60. So minus 3 cubed is minus 27. So because minus 3 times minus 3 is positive 9, positive 9 times another minus 3 gives me minus 27. The next one, minus 3 squared is 9, and 9 times 4 is 36. So that's positive 36, so add 36. 17 times 3 is 51, and we've got minus 17 minus another 3, so that's positive 51, and then we're taking away 60. So we just need to double check it now. So we've got minus 27 plus 36 plus 51, take away 60 gives you 0. So as long as it equals 0, it is a factor.